Hey, welcome to The Explainer. We're all about breaking down huge ideas by going straight to the source.
You know, our story today, it doesn't start with a birth. It starts with a gravestone. Seriously. If you go to Vienna's Central Cemetery, you'll find this tomb, and carved on it is this cryptic-looking epitaph, S equals K log W. Now, that might not look like much, but let me tell you, that's one of the most important equations in all of physics.
So who was this guy? Who was the man behind the equation? And what secret of the universe did he manage to unlock? Well, to get to the bottom of it, we have to look at the man himself. He was a genius, no doubt, but his life was just as chaotic as the very systems he was famous for studying.
All right, let's get right into it. We're talking about a genius in turmoil. The man who trusted atoms, Ludwig Boltzmann. He was an absolutely brilliant physicist, but his career was just this wild ride of incredible discoveries and, well, constant restless moving around.
Just look at this timeline. It really shows you a life that was always in motion. He's in Graz in 1869, then a few years later, bam, he's at the University of Vienna. Then he's off to Munich, then back to Vienna, then over to Leipzig, and then, you guessed it, back to Vienna one last time. I mean, the guy bounced between all these top-tier European universities. He just couldn't seem to stay put.
And you know what? That constant moving around on the outside, it was a perfect mirror for what was going on inside. Boltzmann himself had this theory that because he was born between Shrove Tuesday, a day of celebration, and Ash Wednesday, a day of solemnity, that's why his moods would swing so violently. One minute he'd be incredibly happy, and the next in a deep depression. Back then they called it neurasthenia, but looking back, it's pretty clear he was likely dealing with a severe bipolar disorder.
And this is where it gets really fascinating. This is where his life and his science totally collide. It's almost like his personal battle with disorder gave him this unique insight, this revolutionary idea about how the entire universe works. So let's do it. Let's unpack his legacy, the equation of disorder.
There it is again. S equals K log W. This is it. This is his legacy. This is the equation that finally gave a statistical backbone to the second law of thermodynamics. You know, that fundamental arrow of time that makes sure the future is always different from the past. Okay, let's break it down piece by piece. First up, S. S stands for entropy. And really, entropy is just a fancy scientific word for disorder or randomness. It's the reason why when you shuffle a deck of cards, it stays shuffled. It's why your coffee always gets cold, never the other way around. It's just the universe's natural tendency to get messier.
All right, next up is W. The W actually comes from a German word for probability, but what it really stands for is the number of microstates. So, what's a microstate? It's basically all the different hidden ways that atoms and molecules can be arranged in a system to give you the one big picture you actually see.
Let me put it this way. The macrostate is what you can see and measure. Think about the temperature of the air in a room. That's a macrostate. But the microstates, that's the hidden reality. It's the exact position, the exact speed of every single air molecule bouncing around in that room. And here's the kicker. There are gazillions of different microstates, different arrangements of molecules that all add up to the exact same temperature that you feel. And this is the genius of it all. Think about a deck of cards. How many ways can you arrange it to be perfectly ordered? You know, ace, king, queen, jack all the way down for all four suits. Just one. There's only one way. But how many ways can it be shuffled or disordered? Quintillions, an astronomical number. So a shuffled, messy state isn't just more likely, it's practically inevitable from a statistical point of view. And that was Boltzmann's massive insight. The universe works the same way. It's not that it wants to be messy, it's just that there are so many more ways to be messy. Okay, so the last piece of this beautiful puzzle is K. This is Boltzmann's constant. Think of it as this tiny but absolutely crucial bridge. It's the translator that connects the microscopic world of jiggling atoms to the macroscopic world that we live in and feel. It's what turns the energy of all those tiny particles into the thing we call temperature. And when I say tiny, I mean it. Its value is 1.38 times 10 to the negative 23. That's a decimal point followed by 22 zeros, and then 138. It's an unbelievably small number. And that just goes to show you how little energy each individual particle is contributing to the overall temperature of something you can actually feel. So you have this beautiful, elegant equation, this whole new way of looking at the universe. But, and this is a huge but, the entire thing hinged on one single radical, and at the time, completely unproven idea. The idea that atoms were actually real.
You have to remember, back in the late 1800s, this was a full-blown scientific war. There were two main camps. In one corner, you had Boltzmann and the atomists. They were convinced that matter was made of these tiny, real, discrete particles. But in the other corner, you had this really influential group called the energetics, led by guys like Ernst Mach. They thought the whole idea of atoms was ridiculous. They argued you couldn't see them, so they weren't real. For them, energy was the only fundamental thing, and atoms were just a useful little story, a convenient fiction.
This wasn't just some friendly academic debate. This constant opposition took a massive personal toll on Boltzmann. He wrote that he felt like a powerless individual struggling against the currents of the time. I mean, can you imagine? This constant fight for what he saw as the fundamental nature of reality just fed right into his anxiety and his depression.
And the tough part was, it wasn't just his enemies. Even his friends and allies struggled with him. The great James Clerk Maxwell, one of the sharpest minds around, basically said he couldn't get through Boltzmann's papers. He wrote that the sheer length of them was a stumbling block. So Boltzmann's incredibly detailed, thorough style, it actually ended up isolating him even more.
Okay, so this brings us to the final and really bittersweet chapter of this story. Let's talk about his legacy and his ultimate, but incredibly tragic, vindication.
It's a really sad end to the story. On September 5th, 1906, while he was on vacation with his family, Boltzmann was suffering from another severe bout of depression, and he took his own life. The absolute tragedy of it all is that he never got to see his ideas finally win the day. He never saw them become universally accepted.
But that vindication, it came. And man, it came fast. It's almost unbelievable. Just a few years after he died, the dominoes started to fall. 1905, this young patent clerk named Albert Einstein publishes a paper on Brownian motion that basically lays out a way to prove atoms exist. A few years later, in 1908, Jean Perrin's experiments do exactly that. They confirm it. And before you know it, Nobel Prizes are being handed out for work that stands directly on the shoulders of Boltzmann. Even Max Planck, who was a critic for a long time, was the one who named the constant K in Boltzmann's honor. It was a total reversal.
So when we look back today, what's his legacy? Well, he's the father of an entire field of physics, statistical mechanics. That's a huge pillar of how we understand the world. His constant, K, is literally used to define the unit of temperature. And that equation on his tombstone, it's absolutely fundamental to, well, pretty much everything, from chemistry to how the entire cosmos works.
And that leaves us with one final, kind of mind-bending idea that comes directly from his work. If our ordered universe, with its galaxies and stars and us, is just one possible arrangement, and it's a statistically super improbable one, then what does that really mean? It leads to this wild thought experiment called the Boltzmann brain paradox. And the logic goes like this. Statistically speaking, it's actually way more probable for a single conscious brain, complete with a lifetime of false memories, to just pop into existence out of pure chaos than it is for our entire huge orderly universe to have come to be. So it leaves you with this unsettling question. Is everything we know just a lucky statistical fluke?